our coastal zones are the coral. Okay, that's not a coral reef. That's a barrier beach. My bad. Barrier beach. I was like, that does not look like coral. We are zoomed out really far for scale. These are houses here that you can see. Barrier islands are basically areas near a river mouth or near the land where sediment has gone, like beach has kind of extended itself, and it's building itself around here. So here we have this really cool barrier island, and here that help reduce wave damage. They slow the water down to where these houses are. So, I mean, that's kind of good there. Slows the water down. I mean, whatever. I think that's all we got to say there. But the next one is coral reefs. Here are a few types of coral. Here we have this coral here, and corals down here. Coral, like the forests, give habitat to a bunch of different organisms. And coral reefs, even though it seems strange that these are just a little small things, how can they do so much? They produce a ton of fish for a lot of human populations. When they're going out and fishing, they're fishing around these coral reefs. Coral reefs have the largest biologically diverse ecosystem in the entire world. And we're also including here rainforests. So here we have the most biologically diverse ecosystems existing in coral reefs. Now, corals, like mangroves, typically exist in warmer tropical waters. When you get colder waters, coral actually does not survive very well. The problem is that their shells that they're made up of, like a lot of organisms and mollusks, are made up of a chemical called calcium carbonate. Carbonate was one of those chemicals that we were supposed to learn. So it's CO3 negative. So carbon, 3 oxygens with a negative charge. Calcium carbonate is made up of 1 calcium and then the carbonate molecule, or ion, I should say, bonded together. When that gets really, really cold, carbonate is a really weird thing, and it tends to dissolve in colder waters. So the colder water it is, the less calcium carbonate can be used as a structure for organisms that have shells. All right, so this is going to be kind of hard because this is not the exact same diagram that I could find in your notes, but we're going to try to, diagram this a little bit anyway. This is a messy diagram. But what you're going to do is draw yourself a tiny sketch. You're not going to write everything on here, so don't even pause and try to do that because that's way more information than our brains can handle right now. So you're going to go ahead and draw yourself a little bit of an indication of land all the way to the bottom of the ocean. Okay, next you're going to go ahead and sketch in the ocean surface. I'm going to make really crappy waves because I'm drawing with a trackpad and that's never ideal. Alright, so we've got a few zones that we want to indicate here. One of those zones is the intertidal zone. That's this word right here, so the intertidal zone. The area that's above the continental shelf, so including this area often also in the intertidal zone, is known as the coastal area. So let's go ahead and put in that is the coastal area. Okay, so we have the coastal area here. And so that's all of this area above the continental shelf. The next zone is this zone that's sort of like this lighted zone. So I would draw yourself a nice line here. It's kind of the same color. Let me do a different color there. That did not work very well. There, that one's easier to see. This zone it's actually written right here, is the photic zone, also known as the euphotic zone. So right here, the photic zone, also known as the euphotic zone sometimes. So this is the area in which light is easily able to penetrate. It's the area where photosynthesis can take place. So we might have a little bit of light down deeper that can be detected by organisms, but the main thing here is that it's not enough light for photosynthesis to really be able to be possible. So this is about 200 meters down is the photic or euphotic zone. The next zone here is this next area here. Let's go ahead and mark that out. Oh. This area is known as the twilight or the bathal zone. The bathal zone. So that's right here, the twilight or bathal zone. And then this bottom zone where we don't have any light, we actually call this the abyssal zone. So we call this the abyssal zone. So abyssal right down here. All right, so the main things we want to know here is we've got the intertidal zone, that place where this is as high as the water gets. This is the area where the lowest the water gets. So this is the intertidal zone is a location where there isn't water all of the time. There's only water when there's high tide or something in between, and low tide there is no water. The coastal zone is anywhere above the continental shelf. The photic or euphotic zone is the depth of the ocean. So it could be the open ocean, it can be the coastal zone, it can be the intertidal zone. Anywhere in the ocean where photosynthesis can take place. We've got the twilight or bathal zone, a zone with very little light. And then we have no light zone here where we have the abyssal zone, typically over the abyssal plains, which is what these flat areas in the ocean are called. But I don't think you need to know that, so we're just going to gloss over that like it doesn't exist. Okay. All right, so why are marine aquatic systems important? All right, so remember, separate these two. So first we have our ecosystem services. We have oxygen. So remember, aquatic systems are providing 54% of our oxygen. Water purification, that's going to happen with stuff settling to the bottom. That's going to happen with plants taking up nutrients, plants taking up even pollution. We'll talk about bioremediation later, which is a process where certain plants actually absorb certain toxins really, really well, and it helps us extract them out of the soil. Climate moderation. Aquatic systems help release the heat slowly over time, and they also heat up slowly. So it helps moderate climate. It prevents climate from getting really, really cold and prevents climate from getting really, really hot. So it kind of helps that extreme a little bit. CO2 absorption or sequestration. So carbon dioxide, if you guys don't remember that, I'm sure you guys all remember that one. That's like one of the chemicals everybody knows. But CO2 absorption. So the aquatic systems, especially the oceans is one of our largest carbon dioxide sinks in the world. Part of that reason is because all the carbon dioxide gas that's in the air, when moisture gathers in the atmosphere and it starts to rain, carbon dioxide will actually dissolve into those rainwater drops, and it will just go down into the soils, go down into the waterways, and get into the ocean. Remember, most of our planet is covered in ocean, and most of the water actually falls back down on the ocean itself. So the rain is kind of like a cleansing effect, especially for CO2, bringing that stuff back down in the ocean. Nutrient cycling is a good process too. Almost every one of our ecosystem do this nutrient cycling. So if you're on a test and it's like, oh, what ecosystem service does it provide? Nutrient cycling is going to be an answer for pretty much every single ecosystem we have. Reduce storm damage. That's specifically talking about corals that reduce that wave damage coming in. Coral reefs definitely calm down the waves as they get closer into land, as well as mangroves. Mangrove forests are that type of wetland, the estuary. I think mangroves might actually be closer to an estuary than a wet. I think they might be both. Never mind. They also have a large biodiversity, especially in those coral reef areas. Ecosystem services. Whoops, slow down. Ecosystems. Economic services. So money. So food. Most of the fisheries in the world are along the continental shelves. Clean energy generation, because the waves, we can get energy from the waves. We can also get energy from tides coming in and out. A lot of offshore wind farms are in the ocean, but that doesn't actually come from the ocean. It's just the fact that the wind blows a lot harder over the ocean because there's less friction between the water and the wind. So we get really fast winds off the shore. Pharmaceuticals, so being able to get medicines from these areas. Transportation industry, so we can move in boats, we can transport people. Jobs, and that could be jobs in fishing, that could be jobs in transportation, that could be jobs in ecotourism. And mineral extraction. I don't know if we talked about this, but manganese and magnesium, will tend to precipitate out of ocean water. I know we talked about precipitation as being water that falls from the sky, but a precipitate is just basically some kind of substance that comes out of another thing. So we can actually have these ions floating around in the ocean, and some of these ions will actually start to solidify on the bottom of the ocean, so we can get these manganese and magnesium deposits on the ocean floor. I think we talk about that in a later unit, though, so we'll focus on that when we talk about minerals. All right, so human impact on marine ecosystems is we have a lot of coastal development. People love oceanfront property, and they want to build their house right up there next to the ocean. So we destroy mangroves, we destroy other habitats so that we can get nice and close to where we want to be, have a nice view. We increase runoff when we remove plants from these areas. And we also have a lot of our pollution and stuff moving into there. Here we've got point source pollution and point source pollution. If you don't have these in your notes yet, get them down in your notes right now. So point source pollution, most of you that did the homework understand that that's from one easily identifiable source. Let's say that there's a drainage pipe coming straight from a factory and there's pollution pouring into a river system, and the pollution is a high concentration right there, no concentration upstream, and a lower concentration downstream. That's an example of a point source pollution where we can point exactly to the source of the pollution. Runoff from just cities, this non-point source pollution, is an example of all the runoff that ends up on the road. So grease from cars, sediment that's blown into or washed down the stream, people washing their cars and that stuff going down to drains that end up in the streams in the ocean, any garbage that spills in, any kind of sources that are coming from multiple factories that end up in the same place. We also have stuff we burn into the skies that can rain down and then run off the land that way. So non-point source pollution, are from multiple sources where there's a lot of different pollution sources, and we can't really pinpoint and say, hey, let's stop the source right here and we'll fix this problem. So humans also impact by overfishing. Overfishing You guys saw in our simulation how we can go and there can be plenty of fish in the ocean and we're all fishing there, and then there's plenty of fish, and then all of a sudden in one round in our simulation we had almost completely fished out the ocean. Overfishing of certain populations that we find really tasty tend to cause it so we can't have populations rebounding fast enough. Fishing trawlers, I don't think we've talked about that yet, but these are things that we're dragging on the ground to be able to grab things like clams and that kind of stuff. We drag them behind boats and it kind of rips up the entire ground. We've got things that are growing there like coral. We've got an entire ecosystem that's just churned up. We've added high amount of turbidity, the cloudiness to the water, reducing dissolved oxygen. Fishing trawlers are just not a good thing. They're very environmentally unsound. Invasive transportation, so our boats, we move from one place to the other. We're bringing, like we said, zebra mussels in the one case from one place to another. We are increasing the temperature of the atmosphere, which is also in turn increasing the temperature of the oceans. That's bad for a few things. Ocean warming increases what we call coral bleaching. Coral bleaching is an action when the ocean gets too warm and the algae that live inside of the corals start to die off. They leave the coral, and when they do this, because most of the color of the coral is from that algae, we tend to get the coral turning sort of a white color. If enough of that happens, the algae won't regrow in a certain part of the coral, and that part of the coral will die. Remember, it's an animal, and it lives in a symbiotic relationship with the algae, which uses photosynthesis to create food. So basically, coral bleaching, when the ocean warms, when that algae dies because of the heat tolerance level is exceeded, then they're going to starve to death, basically. Ocean acidification, that's changing the chemistry of the ocean. That's really complicated, and we're going to talk about that in a different unit. A lot of people think it's just, it's making the oceans acid. It's actually not. The oceans are actually basic still with ocean acidification, but it's changing the buffer that's specifically in the ocean. Like I said, skipping that now. We'll talk more about it later in the unit, or not unit, but later in the course. Dredging, again, very, very bad. Dragging stuff on the bottom, trying to collect stuff. Coastal development, that's not the same thing. Sea level rise. Sea level rise affects coastal marine ecosystems in the fact that the sea levels rise and some corals are now deeper in the ocean than they normally would be, and sort of a rapid time, in slower time than they can sort of progress up the coast. This affects them because now they're in deeper water, they don't get as much sunlight, and now they can't photosynthesize as well. So sea level rise affects those as well. Fishing is kind of a no-brainer. And then disturbance of sea turtle nesting grounds. A lot of the time we love to go play in the beaches and screw with the beaches. We create barriers on our beaches which turtles cannot get over or get past to be able to even nest. And if they can't nest, they're not going to lay their babies in that certain area because they don't want to lay their eggs in a place that's just going to be washed over by the sea and then have their eggs kind of be taken out to sea. So that is a big concern for sea turtles, especially when sea turtle populations... Sorry, I hate when it does that. I should put it over there. So sea turtles, they tend to lay like 150, some population, or some species, to 200 eggs in 1 year. So that's a huge amount. And then through a turtle's like 20, 30 years of doing that, like maybe 1 to 3 turtles survive to adulthood to be able to lay their own eggs and procreate. So if we disturb them at all, the honest thing is when these sea turtles are born, they're just mainly food for other organisms, pretty much. Yeah. Anyway, once they get larger, they're not too much hunted, but when they're small, they're pretty much, I mean, they're food for seagulls, they're food for abundant amount of organisms. Another thing with sea turtles that's kind of interesting is not only are their nesting grounds being disturbed, but the higher temperature, because a lot of sea turtles are sensitive to temperature when they're in the egg, similar to alligators and crocodiles. The temperature of the nest often determines the sex of the reptile that's in the egg. So, for example, a warmer part of the nest may end up turning out a bunch of females, and a cooler part of the nest may turn out a bunch of males. So the nest won't have the same temperature all over, and it will tend to produce a varying amount of males and females. We have noticed in some species, some of these sea turtle species, that the warmer temperatures are causing an increase in the females born in each generation. So we're seeing some that only have like a handful of males compared to about 100 females in a nest, which is going to drastically alter their populations in the near future. Anyway, more terrifying things to come in this class. Let's go ahead and skip to the next thing. Fishing. All right, so there's different types of fishing that we need to talk about. So we have trawling, purse-seine, long lining, drift net fishing, ghost nets, fish farming, and then overfishing of predators. It's not really a type of fishing, but we need to not only know what all these things are, but the kind of pros and cons to these things. Now, all of these commercial fishing things are beneficial for the fishermen because they're cost effective. We get a lot of fish with little effort. However, it tends to be very devastating to the ecosystem. Now, trawling, that first one I was talking about, basically we have these weighted things that we pull behind a boat, and there's these nets in back where they basically catch a bunch of the organisms they're looking for that live on the bottom of the sea floor, and then it lets all the sediments through. So they just go slowly through the water, dragging these things behind. You can see in this photo here, here's actually a coral. This is what the ground looks like before the trawling. This is what it looks like after. So you can see it completely wipes out the entire ocean bottom floor ecosystem. Next, purse-seine fishing. Basically, the fishermen let out a net. Let's say over here, they let out the net. The boat travels around in a circle. So they're usually encapsulating fish that are down inside of here. And then they pull up these cords. I don't know if you can see that. I'll zoom in a little bit. They pull up these cords, which actually kind of zip up the bottom. And I like to think of it as zipping up a purse, because that's what it's called, purse-seine. It's not really that's what it means, but that's what I like to think that it means. And then they basically just pull the net closer and tighter, and then they start pulling this net onto the boat, and then they catch whatever fish are in there. So this one is pretty good. It's going to catch a lot of fish, but we tend to get things trapped in here like dolphins. Most of the time they can be released without too much harm. Here, long lining is a really bad one here. So basically we've got a long lining. So think about a fish line, but instead of one hook, it's got a long line with sort of buoys holding it to a certain depth. And then each one of these has a fish hook on them. So this can catch a lot of fish all at once. And then we have a radio beacon here that sends a signal back to the ship that, there is catch on these lines. So what the negative thing here is sea turtles will get caught on these things. Dolphins will get caught on things. A lot of species that we don't intend to be caught on here. And the problem with sea turtles and dolphins are a type of whale. So any of these type of whales or reptiles, these reptiles and mammals that we're catching have to breathe air. And so it may take a long time for this fisherman to come back. And so what we end up finding is these these reptiles and mammals happen to be, they drowned. They die from drowning. So it's not like we can just unhook them and have them swim away and they're fine. They've basically been held under the water and they can't get air. So drift net fishing here, where basically they have this these nets where we have these buoys again. I'm pointing, but I should zoom in there for you. We have these buoys holding up the net in certain areas. And drift net fishing can catch a lot of what we call bycatch, where we're just basically catching everything. We're not really just fishing for one thing or the other. We have these nets, they're down low, and then we just bring them up to the surface, and we have a ton of fish. Now, these can be placed at pretty much any depth and then brought up by a ship. And one of the problems is these can be just free floating into the ocean and anything can get caught in them. They can be hundreds of feet long and extend down through the water column many, many feet as well. Because these nets are kind of indiscriminate, they'll catch anything. Whales can get caught in these things. Again, seabirds, sea turtles, all this stuff kind of get caught in here. They can even mess up boat propellers depending on where they're at in the water column. And again, these can be left completely on their own, and then when the boats come back, they pull them up. They've actually been outlawed in several areas. Some places have completely banned them so that they can't even be used, because they do just catch everything, and they also catch, bycatch of endangered species as well. So for example, Mexico has placed a total ban on any of these type of fishing in their waters because of the fact that they have a lot of endangered porpoises, and they tend to affect those quite a bit. And then the United Nations has also put a lot of restrictions banning these fishing practices as well. All right, ghost nets is not a type of fishing, but ghost nets are basically fishing equipment that people just like, oh, well, we don't really want this fish net anymore, or we're not using this, so they just cut it free and they just let it float in the ocean where it traps things and makes them horrible people. Here's an example of a ghost net that was just let free into the ocean, here kind of destroying these deep sea corals. So these are deep, deep corals that can deal with a very low amount of light, and they're very, very fragile. Think about being in the desert and how we talked about how all those plants are kind of really fragile, and if you break them, sometimes they don't even recover. Same kind of thing with these deep water corals. Another sad thing is, again, these fish nets, these ghost nets, are floating around and they're entangling things that need to breathe air. So things like sea turtles, dolphins, any kind of whale get entangled in these, and they can't swim properly, and then they just drown in the ocean. And that's beside the point of tangling other organisms that end up not being able to swim, and they can't go feed because then they just starve to death. And some sharks actually have to be able to move to get oxygen, so they will suffocate. So not good, not good. There's a lot of ghost nets in the ocean. It's been estimated that most of the garbage in the ocean is actually fishing equipment. Don't quote me on that. I'm not sure on that. I'll check those facts next time we talk about trash in the ocean. Fish farming. So fish farming practices. So you guys in your simulations, for the first time ever I've ever had groups do this, but developed fish farms, which is kind of cool. So we can have fish farms on land. There's actually a very large fish farm in Nevada near Las Vegas, which is totally weird because it's a desert. But there's also these pens that are created offshore. So we have basically a pen. There's a lot of fish in here. They feed the fish, and then they develop here. Here's a guy here for scale to know how big these pens are. And basically just the ocean waters come in and out, and so there's no filtration system that needs to happen in these floating tanks. They're, basically just nets, so the fish can't get out, and nets on the side. So, it's a cool thing here. A few problems with fish farming, however. One problem is the feed that's meant to feed these populations, so that we're not fishing them out of the wild, right? We're helping not reduce those fish populations. The feed that we use to feed these things are small things like anchovies and other things that we get from the ocean that we grind up into fish meal and then feed the fish, which is a problem because we're trying to avoid fishing out certain species, but then we're taking the food source from the ocean because we're not farming the food for these guys, and we're taking that from the ocean. So reducing the food that supports the higher level fish that we're trying to eat in the first place. So that's an issue. So if we could solve that issue and figure out a new feed for these guys, that would be great. The second issue is the same issue you have with any kind of farm where you're farming organisms. In this pen are a high concentration of organisms that stay in the pen all the time. They don't go to a different area in the ocean. They don't come here and there. They stay in this pen. We fish them out. We put more fish in there. So down below the pen, under the water, is a high concentration of their poop that can't be worked through from decomposers and organisms that eat things like poo fast enough. And so we've got to build up an excess of this refuse that tends to lead to toxicity of the bottom conditions in these areas. All right, overfishing of predators. We tend to like things like tuna, like swordfish. We like to fish these things because they taste really good. Salmon is another thing. These are predators, and some of them top predators in their areas, and we tend to be fishing them out way, way too much, which is becoming an unbalance in ecosystems. That's all I'm going to talk about there. Let's move on. Actually, I'm going to go ahead and pause this video, and I'll make a new video for freshwater ecosystems.